Hey there, and welcome to Quick Bites of AI. So grab your favorite snack, maybe a cup of coffee, and let's dive into this fascinating world of neural networks. Now, if that sounds a bit, techie or intimidating, fear not, because we're going to break it down nice and easy. Imagine you're at a bakery, and neural networks are like the tasty layers of a croissant, crispy on the outside and full of buttery goodness on the inside. So what exactly are neural networks? In a nutshell, they are a key technology in the field of artificial intelligence and machine learning. They're designed to recognize patterns and solve problems in a way that's kinda similar to how the human brain works. Well, not exactly how our brains work, because, we're still smarter. Except perhaps, when it comes to remembering where you left your car keys. Now, why are neural networks so important in AI? You see, they're like the Swiss Army knife of AI tools. They can help with things like recognizing faces in photos, predicting stock market trends, translating languages, and even driving cars. Pretty neat, huh? Alright, let's talk about how they work. Think of a neuron like a tiny decision-making unit, and a neural network as a bunch of these neurons working together. They're organized in layers. We've got an input layer that accepts the initial data. Picture it like the batter in our croissant analogy. Then, there are hidden layers, where the magic, or should I say the delicious layering, happens. And finally, an output layer, which gives us the final result, like deciding whether that picture is of a cat or a dog. Not like they're identical twins we can mix up, right? These neurons are linked by weights and biases, which are like little knobs you tweak during training to get the desired result. The weights are adjustable values, and biases are like that extra pinch of salt or sugar that brings out the flavor, ensuring your recipe performs just right. When a network is learning, it goes through these processes called feed-forward and backpropagation. During feed-forward, information moves in one direction from input to output. Backpropagation, on the other hand, is a bit like when you realize your croissants didn't come out right, and you decide to adjust your recipe for the next batch. We use something called gradient descent to help with training, which is like hiking down a mountain. You want to find the quickest way to reach the base without tumbling down, so you carefully choose your steps. It helps adjust the weights and minimizes the error in predictions. Now, real-world applications of neural networks. Oh man, they're everywhere. From Netflix recommending you that perfect rom-com after a rough day, to your smartphone recognizing voice commands. And let's not forget those spam filters, which, might still let through that questionable email from a Nigerian prince. Let's clear up some common misconceptions. Neural networks won't take over the world and create a robot uprising. Well, at least not yet. They're super smart, but they're trained for specific tasks. Ask a neural network, trained for identifying cat pictures, to tell a joke, and it's just gonna stare back at you blankly. Like telling a dad joke at a teenager's birthday party. Speaking of jokes, here's a quick one. Why did the neural network go to school? Because it wanted to improve its networking skills. Oh, come on, it wasn't that bad, admit it. There was at least a tiny smirk. Remember, neural networks are a vast and evolving field, just as complex and layered as life itself. So keep being curious, keep learning, and who knows, maybe one day you'll be baking your own neural networked croissants. Thanks for tuning into Quick Bites of AI. Catch you next time with more easily digestible tech tidbits. Stay curious, folks.